Hello, this is Aditya and this is my lab report on Lab 4 Oscillations. So the purpose of this lab is to observe and analyze the given spring mass system in tracker and plot the x and y position with respect to time and compare these graphs with the one generated from the closed script model. We will also plot the change in energies from the closed script model. A brief overview of the results is that the delta E, the change in total energy, will be zero, and the observed positions from tracker and the positions from the closed loop model will be very similar to each other. So fundamental principles we'll be using in the code are Newton's second law. In this case, the net force is going to be the sum of the spring force and gravitational force. We'll also be using the position update formula, the velocity update formula, the formula for the kinetic energy, formula for the gravitational potential energy. We'll also be using the spring potential energy, and we'll also be using the energy principle, which states that the change in energy in a system is always the sum of work done by the surroundings and the thermal energy exchange with the surroundings. In this lab, the total energy will be the sum of the spring potential energy, the gravitational potential energy, and the kinetic energy. The initial conditions we found from the pre-lecture video and the tracker is that the system is going to be spring, block, and earth. Surroundings is going to be nothing, which makes the work is zero. The mass of the block is about 0.402 kg. The spring constant is around 6.9 Newton per meter. We also found L naught to be 0.127 meters. We also found the block's initial velocity and the initial position from tracker. Here's the experimental setup from tracker. As we can see, there are around 100 points and the corresponding graphs and the corresponding positions. Here's the data and results from tracker. As we can see, the first graph is the graph of time versus the x positions, and the second graph is the time versus the y positions. Moving on to the closed code, we first define the initial conditions. We define mass of the ball, the position of the ball, the initial position of the ball we found from tracker, and the initial velocity of the ball from tracker. We will also update some universal constants like g equals 9.8 meter per second squared. We will also update the spring constant we found and the L naught, the relaxed cylinder spring we found. We will be finding L, which is pretty much the position of the ball minus the spring position, and we'll also find the L hat, and we'll eventually find S. We'll be as explained in the fundamental principles. We'll be using the kinetic energy formula, the gravitational potential energy formula, spring potential energy formula, and the total energy formula in the code. Now entering the while loop, we will define the initial energies. We will also calculate the gravitational energy on the ball. We'll also calculate the spring force. The net force is just going to be sum of the gravitational force and the spring force. We will, with the help of the velocity update formula and position update formula, we'll update the ball's position and velocity for every loop, and then we will also update the L hat. Eventually, moving down the while loop, we will also update the energies and the change in energies. Here are the results from the closed script model. As we can see, we had the change in energy graphs, and we also have the comparative graphs for both model and experiment. In the first graph, we can see that it's x position versus time, and the next graph we can see y position versus time. As we can see from the last slides, the positions from the tracker and closed script model are very similar to each other except for few areas. The possible sources of error for this to happen might be the following. While we did include everything in the system, we did not consider drag force in the closed script model. Drag force did have some effect on the block in reality. There's always a possibility of error within tracker, like calibration error, me just tracking the block very inaccurately, and some possible human errors. Another primary source of error could be that the system in real life is not completely isolated, and there could always be some work done by surroundings which we did not consider. Moving on to the questions, is the energy principle satisfied? Yes, in this case, the energy principle is satisfied because delta E is 0. As we can see in the graph, the orange line represents the delta E, which is 0. All the energies, in this case, the kinetic energy, spring potential energy, gravitational potential energy just cancel out with each other. So we also found the period of oscillations. The average estimation of period of oscillation in the X position is 1.614 seconds. The average estimation of period of oscillation for Y position is 1.519 seconds. Even though these are very close, there is a slight difference of 0.096 seconds. This could be due to drag and also the coupled nature of Spring's motion.